If you have heard about RAG, Retrieval-Augmented Generation, but never set up a vector database yourself, this video is your starting point. Today we are going to get Milvus running locally. Milvus, which is an open source vector database. So you'll have the foundations to start working with embeddings and vector searches. So why does LLM need external memory to begin with? Well, large language models are amazing at generating text, but they can't store or recall large amounts of information on their own. That's where vector databases like Milvus come in. Milvus stores embeddings, which is basically numerical representation of text, images, or other data, numerical vectors to say, that is in a way that makes it super fast to search and retrieve the most relevant information. Now, how does vectorization works and how it's super fast for retrieving relevant information? We'll not get into it right now. But the thing is, even if you have millions of embeddings, Milvus keeps things lightning quick. So think of it as your LLM is trained on a huge data set, but to answer the question, it retrieves the relevant context and then based on that context, it generates the output or answer. And in this video, we'll only focus on setting up Milvus locally. Once it's running, you'll be ready to start inserting and querying vectors. So here's the Docker Compose file we'll use to run Milvus locally. And since we are going to use Docker Compose file, you guessed it, it is a requirement that you have Docker Desktop installed on your device or system. So if you are unsure or never used Docker Desktop, just Google it and the installation will be the first link. So assuming you have that now, with this file we are basically setting up everything we need for the tutorial. Milvus itself, an etcd service, object storage with min.io, and atu, which is the web service or web interface for Milvus. So at the top we specify version 3.5. This is the Docker Compose version, which defines how the services are interpreted. Everything below is organized into services. First we have etcd. Milvus uses etcd for metadata management, basically keeping track of collections, partitions, and other important info. Here we have basic stuff like name of the container, which is Milvus etcd, and then the image tuple, the environment, volumes, health check, which makes Docker wait until etcd is healthy before starting Milvus. Then moving on, we have next up as min.io, which acts as object storage. Milvus can store large blobs like vectors or files in min.io. Port 900 and 901. 900 is the main API, 901 is for web console as per the official documentations. Default credentials we are setting as min.io admin / min.io admin, so that's there. Health check ensures min.io is running before Milvus starts, like previous, so that's there. And you can try localhost 9001 later to show the min.io console. Now this is the core. Standalone runs Milvus itself in standalone mode. etcd endpoints and min.io address links Milvus to the etcd and min.io services that we defined above. Port 19530 is for gRPC that Milvus uses. And talking about gRPC, which stands for Google Remote Procedure Call, it is used for communication between two services. It employs protobuf, which is used for serialization and is basically a binary formatter. Protobuf is an alternative to the common JSON that we see for the communication between services on a browser. The gRPC employs HTTP2 as the transport protocol. Getting back on track, we have ports 19530 for gRPC and 9091 for REST API. Health checks wait for Milvus to be fully ready and depends on ensures that etcd and min.io start first. And finally, atu is the web UI for Milvus. We can open it on localhost at port 8000 to explore collections, vectors without writing code. And at the bottom, networks ensure that all these containers can talk to each other. We call it Milvus here. And now that we have the complete understanding of our Docker Compose file, let's bring everything up. On our terminal, we'll navigate to the folder with the Docker Compose file and run docker-compose-f file path-d. This command will download all the images and start our containers in the background. If we open Docker Desktop, we'll see the container running locally. Now it took very less time for me because I actually had it already run on my local. I had just stopped the container and I re-executed on terminal, so it started everything very quickly because it has already downloaded the stuff and it just had to start the containers. But if you're doing it for the first time, expect it to take some time. So now that everything is up and healthy, that means we are ready to explore Milvus. Next, let's open the atu web interface at localhost :8000, that's the port. The default credentials are what we have defined and pre-filled. So once we are logged in, we can see Milvus is running and the database is up. At this point, you can explore Milvus, check out the UI, and familiarize yourself with the database. Try clicking around, see the empty collections, and get comfortable. Now, if you face any issues following along, drop a comment and I'll make sure to guide you. That's it for today. We now have Milvus running locally, ready for vector data. In the next video, we'll actually populate the database and see live vector search in action. After that, we'll take a step further and connect it with large language model to create a full RAG-based LLM. If you're on this journey, let me know in the comments. If we have enough interests, we'll definitely take this adventure together and make some amazing projects happen. Thank you for watching this video. Let me know your thoughts in the comments and subscribe to stay tuned. Have a good day.